Good day and thank you for joining us. Today we'll be doing a bit of a recap lesson. So we'll be looking at a past paper. So we're looking at June 2018 paper 1. So let me quickly just go over to that paper quickly. Okay, so you can see here we have June paper 1, okay? Let me just zoom in for you guys. So what's going to happen is we have question 1 over here, right? So I'm going to pause. What I need you guys to do is pause this video and do question 1 for me, right? And then once you're done with that, you can resume the video and then I will be doing the solutions for you guys, okay? So if you're watching by YouTube or whatever platform you're using, just pause the video right now. Do these questions for all of question 1, 1.1 and 1.2. And then once you're done with that, you can resume the video and watch the solutions afterwards. Thank you. Okay, so now that you've done question 1, let's look at the solutions. Okay, so question 1 was question 1.1.1. It was 2m minus m to the power of negative 2n over 4n to the power of negative 3. Okay, so if we go about solving this now, what's going to happen is firstly what we need to do is we need to times the top of the fraction, okay? So you can see that we got one term at the bottom, we got two terms on the top. We could divide this term into both terms, but as you can see at the moment, the term on the left does not have an n in it, okay? So what we're going to do is we're going to times these two together. So once we do that, we're going to get 2m to the power of, so remember your laws of exponents, this invisible 1 over here. So if we're timesing these two, we're adding the exponents. So this is 1 plus negative 2, so you're just minusing the 2, so you end up with negative 1. And then you get left over with the n over there. Cool. So you'll have that over now our 4n minus 3. So what you're going to do from there is you're going to look at the thing that stands out, which is the negative 1 over here and the negative 3 over here as exponents, okay? So we know that when we have that negative exponent, what we can do is invert, okay? By invert, I mean if it's on the top, we can take it to the bottom and the sign over here will change to a positive, okay? So how that's going to look is we're going to have 2. So we're going to bring this n to the negative 3 up. We're going to invert the expression, so we're going to be left with n to the power of 3, right? And then we still have this n over here, so we still have to add in that n. So we'll just put it as a times, and then we'll have 4. We bring that m down, so we're left with 4m. So in our final step, we can also simplify this fraction. So we have 2 over 4. We know that, so we have to find the lowest common factor, which is going to be 2. So we'll divide 2 into both of these, so we'll be left with 1 over 4, right? So then we can add in our letters next. So we have n to the power of 3 times n. So you know we're adding the exponent, so we get n to the power of 4 over m. So that will be our final, oh, sorry, my bad. I messed up over here. Obviously, after we put the 2 into the 4, we get a 2, okay? So this answer is going to be 1n over 4, or just n over 4. I mean, 1n to the power of 4, n to the power of 4 over 2m. Okay? So let me just split this in half so we can do another solution on this page. So next up is 1.1.2. So 1.1.2's question goes like this. So it is 2x y squared over 2x times 3y, and all of that is squared. Yeah, cool. Just make sure I'm not missing anything. Okay, I'm missing a square over here. And if I'm not mistaken, that is the entire sum. Cool. So now we can get started on it, okay? So what you could do is you could start with first doing inside the brackets, okay? So what's going to happen is you're going to say it's 2xy squared, and now we'll do the bottom over here, okay? So this is 2x squared times 3y. So what we get is we times the numbers first, we get 6, and then x squared times y will just give me x squared y. Cool. And this is all still squared. So let's try and also simplify our fraction as well, okay? So the way we're going to do that is we're just going to divide, okay? So firstly, lowest common factor, it's 2. So we know we'll have 1 over 3. Then what we'll be left over with is, so we have x over x squared. So we know that when we're dividing, it's minusing exponents, so it's 1 minus 2. So we get x, so that's x negative 1 up here. And then we have y2 divided by y, so that's 2 minus 1, so we're left with y to the power of 1. And this must all still be squared, so once we square it, we get 1 over 9, okay? X minus 2 now, because remember with the rule with the squaring, we times the exponents now, okay? So that's negative 1 times 2, and then 1 times 2, which gives me 2. So now again we have a negative here, okay? So which means we can invert it, right? Once we invert it, it becomes a positive. So we'll be left with on top y squared, and at the bottom 9x squared. Cool, so that should be your final answer for 1.1.2 as well. Moving on to the next page. Next question goes like this. And what they've asked us to do is write this in its full form, okay? Because right now it's in scientific notation. What we need to do is get it down to its full form. So how we're going to do that is, what you can do is you can write down 2596. So we can write down 2596. And we take note of where the comma is, okay? The comma used to be over here, right? So I'm just going to put it in color. Comma used to be over here. And it says times 10 to the negative 6. When it's, 10 to the power of 6. When it says this, we know that this comma over here jumps 6 spaces forward, okay? Because it's positive, it jumps 6 spaces forward. So what happens is we go 1, 2, 3, 4, 5, 6. And underneath each one of these, we'll put a 0, okay? So how it's going to look is, we put a 0 over here, a 0 over here, and a 0 over here, and the new comma is now over there. But you don't need to have that comma in there. This is the number written out in full. As you can see, it is 2,596,000. Cool. So that's question 1.1.3's answer. So now moving on, we're going to moving on to question 1.2.1. So they ask us to expand and simplify these questions, okay? So they give us 5x minus 1 squared, okay? So obviously earlier in the year when we did this example, we said that there's common mistakes that are made, and that is when you just square the inside of the bracket, which is completely wrong. When they say this bracket squared, they mean that you need to times this bracket by itself, okay? So how that's going to look is you're going to have 5x minus 1 in brackets times 5x minus 1. And please note, not timesing out the bracket straight, because then you'll just get 25x squared plus 1, which is incorrect, okay? So we're not just squaring the bracket straight, we have to times the bracket by itself. And you'll see in a minute that we get a different answer. So let's do that. We have of course, you know how we're going to times this out. Times that into that term, and then times it into the second term. And then we'll do the same with this second term over here. It will times into the bracket the exact same way. Cool. So if we're timesing 5x by 5x, we get 25x squared. 5x times negative 1, we get negative 5x. Again, negative 1 times 5x, we get negative 5x once again. Negative 1 times negative 1 gives me positive 1. And our final answer will come to 25x squared. Negative 5 minus 5 is going to give me negative 10x plus 1, which will be our final answer for 1.2.1. So you can see that what the error happens if we just square the bracket straight, we get this answer which is incorrect. You can see we got this answer over here which is completely different, okay? Moving on to 1.2.2, they give us 8x minus 3 and 2x plus 4. Okay, so once again we can see that we have two brackets here. We know we have to times them out. We know how to times them out. So the 8x is first times into 2x, we get 16x squared plus 32x. Right, now we're moving on to the negative 3. It's going to times into brackets the exact same way. So that's going to be minus 6x and then minus 12. Cool. Once we do that, we can get our final answer, which is going to be 16x squared plus 26x minus 12. Cool. Moving on, we are on now number 1.2.3. So we are given 3x minus 1 times 9x squared plus 3x plus 1. So we can be working with the same principles, just a bit different. First term is going to times 1 into the first term, 2 into the second term, and then into the third term. And same is going to happen with our second term over here. That's going to times into the brackets the exact same way. So once we do that, what we're going to end up getting is, so the 3x first timesing in, so it's going to get 27x squared, cubed. Remember, we're adding this invisible 1 over here, so it's 1 plus 2, so we get 27x to the power of 3. And then we get plus 9x squared plus 3x. Cool. Then we're going to move on with the negative 1 times into the bracket, so we get minus 9x squared minus 3x minus 1. So if you're going to look at this line straight away, you can see what can cancel out. We have a positive 9x squared and a negative 9x squared. They obviously cancel out. And a positive 3x and a negative 3x, and they obviously cancel each other out. What we left over with then is 27x cubed minus 1. And that is the end of solutions for question 1. So now moving back over to the question paper. We're going to scroll down now to question 2. And you can see question 2 is actually asking us to factorize the following. Okay, I'm sorry that it's a bit out of frame, but so basically we're just going to be factorizing the following over here. So we have 2.1, 2.2, 2.3, 2.4 and 2.5. So just like before, what you're going to do is you're going to pause this video, and once you're done doing the examples, you can play the video and watch the solutions afterwards. Thank you. Okay, so now that you've done with all of these examples, we can move on to their solutions. So we'll head back over to our page over here, and we can start doing the solutions. So we're going to be doing 2.1 first, so this is question 2, 2.1. So remember they're asking us to factorize the following, okay? So the first one goes like this. Okay, so first thing you're going to want to look for is obviously what number is the smallest of here. As you can see, this is just going to be the basic common factor factorization. So we'll look for common factors. So lowest common factor between the numbers. Unfortunately, we can see that 3, 4, and 12, there isn't no really lowest common factor except for 1. So we're going to have 1 over there, but we don't have to write it down. If we're looking at x, we need to see which is the lowest x value. You can see we have x to the power of 1 over here, right? X to the power of 1, so we know we can only take out 1x. And the lowest y, we can see we have y to the power of 1 over here, so we can only take out y to the power of 1. So we're going to take that out of these over here. So what we're going to be left over with is 3x squared. Remember, this is using your laws of exponents. So now remember, what's happening is that we're taking out the x and the y. So we're taking out the 1x. So we're going to say x3 minus 1. So we get 2 over there. And we have y1 minus y1. And we get, and they cancel each other out, okay? Moving on, we get negative 4x to the power of 3 minus 12 to the power of, now you can see we have x1, they cancel each other out, so it's y5 minus y1, just going to give me y to the power of 4. And that will be our final factorized answer over here. Moving on to 2.2, we get given this. So straight away we can see how we would be able to have a common factor in here. That's if we had x minus 8 and x minus 8, but this is 8 minus x, okay? Remember how we solve that is how to switch the 8 and the x around. So how it's going to be done is we usually do switching of this sign over here. Once we switch that sign, inside here we get x minus 8 now. So they switch around once you change the sign over here, okay? Once that's happened, we can see now we have a common factor of x minus 8. So we take x minus 8 out of each side over here. So we're taking x minus 8 out of x minus 8. So we know that it's going to be 1. Now we'll put in this minus sign, right? And then we're saying 8c x minus 8. So now we're dividing this by x minus 8, so we know it will cancel out. So we're just left with 8c. Cool. If I can just show you a more simpler way, let's say we wrote it out again, minus 8c x minus 8. Remember we took out x minus 8 as the common factor, so which means that we're dividing by x minus 8 over here, and we're dividing by x minus 8 over here. So we can see it cancels out here to make 1 on the left hand side. On the right hand side it cancels out and we're left with negative 8c. So that's how we get the 1 over here and the negative 8c. Okay, moving on. Moving on to 2.3. It's going to be our first trinomials example. So we get x squared plus 7x plus 10. Cool. So remember trinomials, we can use this rule over here, a times c and b. So if you're looking at a, which is our first term, and c, which is our third term, you're going to times them together, the numbers. Remember there's an invisible 1 in front of here. So 1 times 10 is going to give me 10. And then b is 7. Okay, so we're looking at the number values. Now, we're going to look at what two numbers can we times to get to 10, but add to get to 2. So if you look at that, you'll eventually get to 5 times 2 gives me 10, and 5 plus 2 gives me 7, right? So we already know what terms to put into our brackets. So we're going to split the x over here because we have an x squared, so we're splitting the x. And so we have to put in our 5 and our 2, and they're both positive numbers in here, so they'll both be positive numbers in the brackets. So we have plus 5 and plus 2. Cool. So that's our final answer over there, factorizing 2.3. Now we're moving on to 2.4. So in 2.4, they give us 5x squared minus 11x plus 2. So we can see a bit different. We have a bigger coefficient here in front, okay? So I'm going to show you how we deal with that. When we have this bigger coefficient, we know we have 5x squared, right? So what I want you to first do is write down 5x and then 5x again. Okay, so we're just going to keep it like that, okay? And we're going to do our normal a times c and then b. So our a times c, 5 times 2 gives me, once again, it gives me 10, right? And then we have negative 11. Cool. So now, what can I times to get to 10 but add to get to negative 11? So clearly because it's a negative 11, we'll have two negative terms, okay? So what we can do is times negative 10 times negative 1, which will give me positive 10, and negative 10 plus negative 1 will give me negative 11, right? So we know that we can have negative 10 and negative 1. So negative 10 in there, negative 1 in there. So now we have to look at, once we get to this point, because you can see we can't necessarily have these 5x's here, because if we times them, we get 25x squared. So what we have to do is get the common factor out of both of these brackets, okay? So if we look at this bracket on the right, there's no common factor we can take out, okay? Out of this bracket. But if you look at the bracket on the left, there's a clear common factor we can take out, and that is 5, because 5 goes into 5x and goes into negative 10. So once we take out the 5, we get x minus 2. And on this side, we still have 5x minus 1. And then what you do with that 5 is, we just cancel it out, it goes away. And our final factorized answer is going to be minus 2, x minus 2, and 5x minus 1. And if you times that out to check your answer, you will get straight back to our top expression over here. Therefore, this is properly factorized, okay? So very important to note what we did here. We split the 5x squared into 5x and 5x. We did our a times c and our b rule as we usually would. We put it into the brackets, and then we see which brackets we could simplify by taking out a common factor. Once we took out the common factor, we got rid of the common factor. Okay, we just scratched it out, and then we had our final factorized answer. Okay, so now moving on to the last example. We can see we're given x to the power of 4 minus 2x squared, y squared, minus 8y to the power of 4. Okay, so this is a slightly more complicated example. So I need you guys to pay very close attention if you didn't get this, but if you did get this, very well done. This is quite a challenging example. Okay, so what I'm first going to do is I'm going to open up my brackets, right? Now what you need to look for is what's given to you, okay? So you know you have x to the power of 4 and y to the power of 4 over here. So we're not going to worry about the numbers yet. We're just looking at the letters, okay? So we have x to the power of 4. What can I times to get to x to the power of 4? So you know the laws of exponents. If you're timesing x squared by x squared, you're going to get x to the power of 4. So what you're going to do then is you're going to put in x squared and x squared. And now you need to think about y to the power of 4. What you're going to do to get to that? You can do the exact same thing. Okay? So you're going to do y squared and y squared. But obviously you need to make sure that these exponents over here match up with the exponents here in the middle term, okay? So you can see we have 2 and 2 on x's and y's, and you can see that here we have x and y as 2's as well, okay? So you can see that we're timesing this and it will give us x to the power 4, and we're timesing this and it will give us y to the power 4, and they need to match up with the middle term's exponents as well. Cool. So now we can do our normal a times c rule and then b. So what it's going to look like now is we're going to do a times c, which is 1 times negative 8. Remember, the sign goes with the number. So 1 times a negative 8 is going to give me negative 8. And then b is negative 2. Cool. So what can I do? What can I times to get to negative 8 and add to get to negative 2? So after looking at it for a while, you'll finally see that it is negative 4 times positive 2. Because if I did negative 4 plus 2, I'd get negative 2, okay? So we're going to use the numbers negative 4 and 2. So it doesn't matter which bracket you really put it into, you'll just get, so it's negative 4, so we'll put negative 4 over here, and negative positive 2, sorry. So it's positive 2. And as you can see here, we got our answer over here. Now, if you want to, you can check your answer. So the way you're going to check your answer is you're just going to times out these brackets and see if you get back to this main term over here. So if I times this out, I get x to the power of 4 first. Then I get plus 2x y squared. So you see I times 2x squared y squared, sorry. I times the x squared into the second term that time, okay? And I got 2x squared y squared. Then I times negative 4y squared into x squared, and I get negative 4x squared y squared. And I times negative 4y squared into positive 2y squared, and I get negative 8y to the power of 4. So now it's all a means of simplifying now. I leave my x4 as it is. So these are the like terms here in the middle. So 2 minus 4 is going to give me negative 2. X squared, y squared, and then minus 8y to the power of 4. And as you can see, this answer over here at the bottom matches up with our expression at the top. Therefore, this answer over here that we've gotten for factorization is correct. Okay. Okay, well, thank you for joining us. I hope that this session did help you with recapping all of the work that we've covered so far. Next week, we'll carry on with this question paper just to cover more of the work that we've been through already. Thank you very much for joining us, and go well.